So we are not going to see which button to click, where to click, which one to create. No, that's not our focus. That can be learned at any time. There are many people in the internet who teach us those things. But these things which we see, it's very rare to see, rare to hear. Now this one is going to talk how the forwarding happens inside the ACI fabric. What are all responsible for the successful layer 2, layer 3 and layer 4 to 7 service insertion. What are all involved in that is what this chapter is about. It's very important core knowledge in ACI. ACI is an overlay concept where we have a lot of VXLAN tunnels. These tunnels are dynamically created for the endpoint groups. What is endpoint group? EPG. EPG is a group, a bridge domain that has got collections of devices, many number of devices that may be in different subnets, but they all have one common function to do. Those devices is what we call it as EPGs. The devices that have got common function, we put them in one group called endpoint group, EPG. So we may have let's say clients, all the clients in one EPG and all the servers in another EPG. This is one example to understand EPG. Clients and servers. Between client and the server, what do we have? ACI fabric. Now these clients may be trying to reach a server which is in another EPG using a layer 2, or it may be even using layer 3 if they are in different network. Our ACI fabric needs to support this now. Members of two EPGs wants to communicate. Client and the server wants to communicate. If client and server are in the same subnet, you need layer 2 bridging. If it is different subnet, then you need layer 3 switching. When we say layer 2 switching, bridging, we use bridge domain. When you say layer 3 switching, we use VRF. In ACI we use VRF. So all these things, are in the fabric. Fabric has to do all this thing automatically. Without you knowing all this things that are happening behind the screen, this all happens. You just, for a couple of days you did ACI lab without knowing all these things. You did a lab successfully and it shows the result, very nice. So what all you did so far is just understanding the tool, using the tool, but you don't know how it works behind the screen. How the tool makes the fabric to work is what our today's class is. Now after knowing these things, when you go back and do the lab again from the beginning, you will have better understanding about that ACI. So this lesson, this class, today it may be also tomorrow, continuing, this is going to be most important than what you have done for this many days. To understand that, you need this. Okay, coming back. See, this ACI fabric is very dynamic. And we are going to see how this ACI forwards traffic between one EPG to another EPG device, which may be in the same switch, may be in the different leaf switch. The destination may be in the different leaf switch, may be in the same leaf switch. The destination may be a known destination, the destination may be an unknown destination for the leaf. How ACI is going to forward the traffic is what this chapter is about. How ACI can transport our traffic through the tunnel overlay, VXLAN tunnel. And also we'll be learning about leaf and spine endpoint learning. Leaf and spine endpoint learning. Leaf endpoint learning is the data plane learning. What is data plane learning? As the traffic comes in from the source MAC address, from the source IP address, the whereabout of the endpoint is learned. Where the endpoint is. How you know? When the packet comes to a leaf, leaf learns the source and source MAC address and source IP address, and now leaf knows that I got a endpoint device connected on me locally on this port. That is what we call as data plane learning. As the traffic comes in, from the traffic, from the packet, when you learn the location of the source device, that we call as data plane learning. Leaves learn about the endpoint devices in the data plane. That is the meaning of what I explained. The meaning of this is what I explained. The leaf endpoint learning in the data plane. As the traffic comes in to the leaf from the end devices, leaf learns about the end device MAC address, end device IP address /32 address locally on the switch. We call this as data plane learning. It is not a control plane learning. Did you learn the source and the source IP address or MAC address using a routing protocol? No. Was it advertised? No. As the traffic enters, you know the end device. More deep into this, we'll be going next. Spine also learns about endpoint. But we all know that no end device will be connected to spine. See the big difference. Leaf can learn easily the end devices, because leaf is connected to end devices. Leaf is connected to end devices, it can easily learn. But how spine can learn the end device? Are we connecting any end device to spine? No. Spines are connected to leaf alone. But spine also learns about the end device, the EPG members. Every spine knows about all the devices. It may be a VM, it may be layer 3 domain or layer 2 domain, physical domain, whatever. Spine knows about everyone on every leaf. One leaf may not be knowing about another leaf, but spine will be knowing about every members of all the leaf. But no end devices are connected to spine. Then how is this possible? How spine learns about all the end devices that are locally learnt on the leaves. It is through this Council of Oracle protocol. This Council of Oracle protocol is a protocol that is used in between the leaf and spine which makes the leaf to report about the end devices that are connected locally to the spine, so that spine can maintain a database of all the end devices. So every leaf will go and report to the spine. Like OSPF, DR other routers go to DR and report to DR. Here all the leaves go and report to spine. Spine now learns all this MAC address and IP address of end devices and stores it in a table called Kube's database. Council of Oracle Protocol database. Please understand this. Leaf will learn it. Leaf will learn all the end devices in a local endpoint table. That's the name of the table, endpoint table. Endpoint table, which is a table seen only on leaf, which has got information of IP address, MAC address, VTAP address. It's a local database, but it is not a Kube's database. It's a data plane table, endpoint table. In spine you don't see any endpoint table. Why? Because you don't have any endpoint connected to the spine. Then where it is saved? In spine it is saved in Kube database. How the Kube database is built in spine? Based on the endpoint informations that it received from the leaf given to the spine using this Kube. That's how spine knows about every end devices on every leaf. What is the purpose of spine knowing about the end device? We will see that as we go inside. That will be very interesting. See, I was using an example OSPF designated router. Do not take 100% spine will be like on DR. No. See what in OSPF does. In OSPF, when a DR other sends the information, route information, link state advertisement, DR will receive it. After receiving, it will also forward it to other DRs. Correct? But the spine will not do that. Spine will never push information to leaves. Spine will be collecting all the infos like a backup designated router in OSPF. You can say like that. Spine is like a BDR in OSPF. It will simply learn everything that leaf gives. All the IP address and MAC address of the endpoint devices. And it will store in a Kube database along with the VTAP address. How the leaves are identified? VTAP address. What is VTEP address? Virtual tunnel endpoint address. So that's the ID for leaf and spine. So when a leaf is sending an information about the end devices from the local table to the spine, it will send along with its tunnel endpoint address. So in the COOP database, spine will know which leaf has got the end device with so and so MAC address and so and so IP address. So how the COOP database will look like? It will have the VTEP address for all the MAC addresses and the IP addresses received from different leaf. Next, we are going to go in deep. The entire chapter is about this only. I am just giving you overview of what we are going to learn. Next point is policy based rewrite. It is not policy based routing. It's not policy based routing. Usually PBR means for networking people it is policy based routing. No, it's not that. We are here seeing policy based rewrite. What is that policy based rewrite? See, I want to go from Cochin airport. I want to go from Cochin to Sweden. Atlanta airport, Sweden. My source is Cochin, my destination is Ireland. So my source is in leaf 1 and destination is in leaf 10. Two different EPG members. Cochin is one EPG member, Ireland is another EPG member who wants to communicate. But if you want to go from here to there, for some reason you need to go to assume, for some reason you need to go to Copenhagen. Copenhagen is another intermediate airport. You need to land and take another flight if you are going through Air India. Air India will take you through connection flights. So from Cochin to Copenhagen, you land in Copenhagen. Copenhagen is also part of Europe. You land there. And then you take another flight to go to Sweden. But your destination is not Copenhagen. Your destination is not Copenhagen. Your destination is Sweden. You bought ticket for Sweden, not for Copenhagen and Copenhagen to Sweden. You did not do that. You bought a ticket from Cochin to Copenhagen. Cochin to Sweden. But the airliner is a PBR, policy based redirect. Policy based redirect. The Air India is a policy based redirect. What they do, okay, for this customer who wants to go to Sweden, we don't have a direct connection. If he wants to go there, let us send him to Copenhagen. From Copenhagen, he will get transferred to another flight that takes him to Sweden. Who decides that? You? No. You bought a ticket for Sweden. Your source is Cochin. But As a policy, you are redirected to Copenhagen because you choose Indian flight called Air India. If you would have taken some other flight like Lufthansa, you would have not got this PBR, policy based redirect. Because you took Air India, you underwent this redirect, which you really don't know. You go and land in Copenhagen, and Copenhagen will decide whether to send you to Sweden or not. And if it grants permission, then you take another flight, you go to Sweden. But this, you have no idea. Your packet needs to go from client to the server. Now I am coming to the actual networking story. Try to correlate with that to this. Traffic wants to go from client to server, which are in two different EPGs. So you are sending the traffic, client is sending the traffic. But in the middle, the packet is being redirected to the firewall. And firewall will now decide whether to proceed forwarding this packet or not. If it finds some abnormality, it will not forward to the server. If it is normal, then it will allow the traffic to go to the destination. See, sender don't know about the firewall. Sender is sending the traffic to whom? To the destination, to the server. Client is sending to the server without any knowledge that we are going to be redirected to a firewall for layer 4 to layer 7 inspection. Has got no idea that we are going to be inspected. He sends the traffic, but the service graph, it says, oh, you are coming, I know what to do with you. Let me first scan you. And it sends to the firewall, which is totally against the routing table's decision. Who decides this? Service graph. That is why it is called a service, firewall service. The graph is given. This is the service graph you need to follow if he is going to meet the server. If that EPG goes to that EPG, if this is going to that EPG, this is the service graph. It's not IP route, but it's a service graph. Traffic should be pushed to the firewall, and firewall should grant permission, then you forward it to the destination. This is what called as service graph with policy based redirect. We are going to go in depth of all these things. So whatever I have spoken now is already clear. I made it very clear, though it is the very first page. I have told the entire story in a very short manner. Detailed story is what we are going to see for a couple of days maybe. It depends. Did you understand so far? Next, you see, these are all the things that happens while forwarding in ACI fabric. Number one, ACI decouples the endpoint from the location. Meaning, devices are not immediately identified with MAC address or the IP address. They are identified with the bridge domain, the endpoint group. In our traditional network, we used to identify the device with the MAC address. How do? You write an access list. Even today in BGP class, what we did? We wrote an access list to identify those network updates coming for network 155.155. That is how we used to identify. But ACI never do that. It decouples the fabric, decouples the endpoint from its location. So no more it is binded to an interface. If you see access list, where you will bind to take an action, whether to permit or deny, we used to bind it on the physical interface if you take normal access list. So only when you pass the interface, pass the traffic through that interface, that ACL will be checking the traffic. If you connect through some other interface, ACL cannot stop you. ACL cannot check the traffic. So it is like, binded to the location, binding to the port number, the physical port ID, interface ID, many more things. That is how the traditional network does. But ACI is not like that. ACI first decouples it. Based on the bridge domain to which the endpoint group is connected, the VXLAN encapsulation will be done based on the EPG. Based on the EPG, bridge domain is determined. Based on the bridge domain, VNI, VXLAN ID is attached to the traffic, and it takes a overlay tunnel. When the traffic is moving through the ACI fabric from one leaf to another via spine, there is no original MAC address, source MAC address or destination MAC address, or in use in packet forwarding. It is only the encapsulation. It's only the VNI that moves the packet. That is why the first point says decouple the endpoint from the location. Inside the ACI fabric, the packets are not switched based on your original source or destination MAC address and IP address. It is all based on the identification that is provided by the ACI, like the tunnel endpoint address, the VNIs, the multicast address. These are all things that is going to the MAC address of the leaf, the MAC address of the remote leaf, the MAC address of the leaf, the MAC address of the spine leaf. They are all the one which is going to determine the path. Not your original MAC address or IP address or destination MAC address and destination IP address. That's what the first point says. Fabric decouples the endpoint from the location. ACI forwards it based on the VXLAN encapsulation. ACI fully depends on VXLAN. That's why we did VXLAN as the first topic before entering into ACI. So we learned VXLAN, in which you did everything manually, EVPN for the control plane, multicast address for the flooding, all those things we did manually. But ACI does the same VXLAN but in a very advanced level, not same VXLAN. VXLAN with more advanced thing embedded, encapsulated. Only those who have that idea of how the VXLAN in command line we configure will understand this ACI, how it does the tunneling. Here everything is dynamic, there everything we need to do manually. But to understand this ACI, we need to have some knowledge on VXLAN, because this uses advanced VXLAN. But you don't configure anything related to VXLAN. All those things are dynamically created here for in ACI. Now, when a traffic enters into one leaf, based on the bridge domain, based on the EPG, the policy that is attached to the EPG is now attached to every packet that is sent from that EPG member. So usually when you go to foreign countries, it is recommended to keep your passport in your packet whenever you roam around in a foreign country. People used to say, I don't follow that. People used to say you should carry your passport whenever you are going outside. Yes, Likewise, in ACI also, every packet that goes out from the leaf towards the spine till it reaches the other end of the fabric, means the remote destination leaf, the policies for the packet for the policies that need to be maintained while the packet moves need to be carried, will be carried. Policy identification is carried in every packet. Between one leaf to another leaf, every packet A has got its own policy, B has got its own policy. Packet A may have a policy to go through a layer 4 to layer 7 inspection. B may not be having that policy. B will go directly from source to the destination, but A needs to go through a firewall policy, So those policies are carried on every packet. Next, the leaf and spine communicates with each other with infra VRF. I was talking about the information that are shared in between the leaf and spine earlier about the endpoint. The informations are shared, communicated between leaf and spine. That uses Oracle, means Council of Oracle protocol and ISIS protocol. See, ISIS is the routing protocol inside. And this uses this VRF called infra VRF. It is using the infra VRF, the communication happens in between the leaf and spine. So if you will see a VRF called infra, when you configure ACI, you have come across this. This is not new because you have done lab once. And you might have sometime wondered why you need this infra VLAN. So you see here, this is a purpose. This VRF is a common VRF in a common tenant. There will be a tenant called common, which we did not create. It will be there by default. So it is the infra VRF which is going to be used for leaf spine communication. Next, leaf performs the tunnel endpoint address. So leaf is the one which is going to have the complete policy end to end for a traffic to go from one leaf to another leaf if it is coming from one particular source. So those things are processed on the leaf. When a packet enters, the leaf will say, hey, this packet should go like this only. This is the policy. So according to the policy, VXLAN encapsulations are going to be done now. It may be a layer 2, it may be a layer 3, depending on that, VXLAN IDs will vary. It may need to go through a firewall. Depending on that, a VXLAN ID is added, using which the packets are now going to be forwarded inside the fabric. Every leaf is identified with a tunnel endpoint address. What spine does is, spine performs any cast tunnel endpoint address. Any cast. What is any cast?
No, it is I actually.
One to the closest. One to the closest. Whichever the spine that receives the packet first, that will forward the traffic. So spine performs any cast tab. For spine, there is no need for all spines to be part of all data forwarding. Any spine, whichever receives the traffic, will form a tree. When we say tree, it is nothing but a IP path, in such a way that there will be no duplication of packet. Sometimes, if a packet goes through multiple spines, then on the receiving side there will be multiple duplicates. That's why spine performs any cast tab, tunnel endpoint, using which there can be duplication avoided. More detail of this is coming later. That will be like MAC address learning, endpoint learning topic. We'll be seeing that later. So this is what I was talking about. Location of the device is decoupled. Means what? Your original identifier, the original source and destination, is not utilized while forwarding the traffic within the fabric. Within the fabric, it is only the leaf to leaf VTAP address is important for the packet forwarding between the leaf to leaf. Right? And then for every traffic, there is a policy, there is a flow control, there is a VXLAN encapsulation. I also said hoops is involved for the spine to know about the endpoint information such as MAC address and IP address. ISIS is also involved, using which this reachability is provided. So based on the policy, the tunnel VXLAN encapsulation and the tunnel is determined and the traffic flows. Spine uses anycast tap address, which we spoke as the second last point, using which the traffic will be forwarded. Now you will get a more clarity on this any tab in this slide. In this slide, last 2 points. Now you were asking about a doubt. You asked me a question a few minutes before the break. You asked me a question, and the question also will be answered in this forwarding scenario lesson. See, we have 4 different scenarios in which ACI need to forward the traffic. Number 1, source leaf knows the destination, and the destination is also in the same leaf. This is one scenario. Another scenario is the source leaf knows the destination, but the destination is not in the same leaf, it is in the different leaf. Third scenario is source leaf does not know the destination. This is your scenario. Source leaf does not know this destination. That is what third and fourth scenario. See, fourth also same. Source leaf does not know the destination. So in this third and fourth, you have different solution, 2 different solutions. Spine proxy mode and flooding mode. Definitely you have configured this under the bridge domain. When you did the lab, you selected one of this. You might have selected spine proxy mode or flood mode. Definitely you have seen this page in the GUI, but you did not know why you are doing that. Now you are going to know it. Now the first scenario, What is that? Source leaf knows the destination leaf, and it is the same leaf. In this case, how the packet will be forwarded? Normal switching. How a normal switching happens in your catalytic switch? Same like that. Looks the MAC address, forwards the traffic. Will there be a VXLAN anything? Nothing. Normal switching. Next, source leaf knows the destination, but the destination is in the different leaf. If the destination is in different leaf, you know the IP address of the destination leaf. What is the IP address of the destination? The tunnel endpoint address. Who knows it? But source leaf knows it. It is cached. Using the conversational learning, it is cached. It is, though it is a data plane learning, it is again conversational learning. It will not be saved in a endpoint table. The destination leaf information will be saved in a cache. Using that information, cache information, it knows the destination leaf. Now the packet need to be forwarded to the destination leaf VTAP address. That's all. It will be forwarded by using multipathing, equal cost multipathing, using all spines. Do you have any question on this first two?
So my doubt on the first one is, if it's the same leaf, so what happens in the ordinary switch? It will be like flooding into the whole broadcast domain.
Why?
And then it will reach the destination.
Why in a normal switching it will flood, you tell me? When source knows the destination, when the leaf knows the destination, or in a normal switch, when the switch knows the destination where the destination is connected on the switch, why it will flood, you tell me?
Yeah, if it is knowing about the MAC address and the port, then it will directly switch to.
That is what it means, knows the destination. Source leaf knows the destination, and the destination is in the same leaf. Why there is need for flooding, you tell me? There is no need. Yeah. Because it is there in the local endpoint table. On the leaf, local endpoint table, see, endpoint tables are more powerful than MAC table. Endpoint table will have not just the MAC address and the port number, the interface number. It knows the interface name, MAC address and IP address. So it's more powerful. So there is no need to even flood for ARP. There is no need to flood.
Okay.
When an ARP request comes from source, switch will say this is what the MAC address of this IP address. So there is no need for flooding even in the case of ARP. Protocol is used, but the protocol will not be flooding all the time. It knows the answer from the leaf, sometime from the spine if it is needed, from the spine if not leaf having it. We are going to talk about that in the third point. Now, do you have any question on the first two?
No, sir. Yeah.
So the second one also, let me repeat. The source leaf knows the destination leaf, meaning the source leaf knows the VTAP address of the destination leaf where the destination server is connected. So it will simply use that as the encapsulation for the destination VTAP. The encapsulation with the VXLAN is done to the packet, and packet is going straight to that leaf, and that leaf decapsulates the packet and it finds the inner destination and it delivers to the original source outside the southbound, outside the leaf. That's 2 point over. Now third one. A packet is arriving to a source leaf. Listen. This is very important, fundamental in ACI. A packet is coming to the leaf. The leaf Even if you don't know the source, now it will learn the source. How? When a packet arrives, it learns that is what called as data plane learning. It learns now the device, the source device, and the MAC address in the local table, local endpoint table. Now it is looking for the destination. Let us assume there is no destination in this leaf. In this leaf there is no destination. What it will do, if you would have set it as spine proxy mode, if you would have selected for unknown destination, if you would have selected an option spine proxy mode, the destination MAC address will be now spine device, not the remote device. See, the original destination is remote only, but the packet now needs to go from leaf to the spine first. That is what called a spine proxy mode. Because the source leaf do not know about the destination, it will forward the traffic to the spine. Spine, if it knows, definitely spine will know. Why? When you connect any end device to any leaf, immediately that leaf gets updated with the new device that you attached, information about the new device that you attached. As soon as a new change happens to the local database in a leaf, local endpoint table in a leaf, Coop will take that information and put it to the spine. So, as I said earlier, spine will know about all the end devices. So you simply send it to the spine, and spine will just change the destination of the packet as the original destination to where you need to send the packet. Source will not be changed. Repeating again, I want to repeat this with the diagram. You will understand better.
Is it like when we create a virtual distributed switch, it will learn all the VMs, MAC address, IP address, and
everything. Yes.
Okay.
Now, this is spine and this is leaf. A wants to go to B. As soon as you connect B, this knows that there is a B, and the VTAP address, let's say 1.1.1.3. And let's say this VTAP address is 1.1.1.1, and the local table here knows that I got A on port number, let's say E0. Let's say here E24. This is what endpoint table, local endpoint table. The entire endpoint table will have this port number, the IP address, and the MAC address, or even IP address also. Now, I'm not writing MAC address, IP address, I'm just simply writing A. Now, this spine knows very clearly in its COOP database, which is a cache, which is updated using COOP, Council of Oracle protocol, saying I got B on 1.1.1.1, 3 VTAP, and I got A on 1.1.1.1. Now, this leaf 1 do not know about B. Leaf 2 don't know about A. It is okay. They will learn only after the first conversation. Who will learn? Leaf 1 will learn about B only after conversation. That is conversational learning. And where it will learn? It will not learn in the endpoint table. It will be learning in a cache. Remote endpoint informations are not saved in endpoint table. Remote endpoint informations are saved in cache. And when the cache will be updated? Only when the conversation happens. So far no conversation happened. This is the first time they are going to communicate. So when A tries to talk to B, A do not know about the destination. If A do not know about the destination, there are two options. Either you use spine proxy mode or flood mode. Now we are discussing about the spine proxy mode. What is what it is? Leaf 1 will forward the traffic to spine. Spine's address, let's say spine's VTAP address is 1.1.1.2. So the upper layer, see, inner layer has got A as a source and destination as a B. There is no change in that. But the upper layer, the VXLAN ID, is going to have the source of 1.1.1.1. Because you don't know the destination 1113, it will simply send it to 1112. The packet goes here. This guy knows this one, B. After removing this, it knows B. B is in 113. So what it does, without changing the source, it won't change the source. Without changing the source, see, source is still same 1111. 1.1.1.1. Without changing the source, only the destination it will change. Earlier the destination was 1112. But now spine now rewrites it. It says 1113 and forwards the packet here. This checks the destination, it matches, so it decapsulates. It finds the original destination, it delivers the packet out using this port number E24. Now when the reply comes, see, it has already learned that there is someone called A in 1.1.1.1 from this packet that it received. That is why spine was not changing the source address. It helped leaf 2 to learn about the location of A. Now it won't do spine proxy. B will directly deliver the packet, the reply packet coming from source B to the destination A. What will be the upper layer? VXLAN header, source 1.1.1.3, destination is 1.1.1.1 because it has learnt it. This is what called as conversational learning. This and this will not be in the same table. This is what called as endpoint table, local table. This is what called as cache, remote endpoint cache. Remote endpoint informations are saved in a cache memory. Cache. So using the cache, it knows the destination and now it delivers the packet directly here. Though it is going via spine, it is delivered to, it need not to go through the spine. Now as the packet comes in, this now knows in the cache that B is connected to 1.1.1.3. Is it clear? Conversational learning.
Yes, sir.
Right. If you don't choose this as an option, if you don't choose spine proxy mode as an option, the other option is flood mode. It will simply flood to everyone in that bridge domain. Within that bridge, within that VXLAN, all the members will receive it and only one will be responding it. There may be many leaves involved in it. All the leaves who belong to, who has got members of the same bridge domain will receive it, and one of the leaf will have the destination which will respond back. Flood mode uses that multicasting. Flood mode we did in VXLAN class. Without EVPN, it is flood mode. Yeah. So your wish, you can go for flood mode or spine proxy mode. This flood mode may be beneficial when you have this virtual distribution switch, VDS, in the VMware. Sometime there may be some MAC address which was not really actively sending any traffic, so leaf did not learn. So when you flood only, leaf will get chance to learn through the response packet from the VM. So if you are working on a VM environment, mostly you will enable flood mode, otherwise it's not necessary. That's why you told me in your lab you enabled flood mode. It is maybe because of the VMM. Your lab that you are working is not the physical domain, it's VMM domain. Yeah. So did you get answer for your question?